Yeah, Zoom challenges.
Yeah.
So a little about me. My name is Odefunso, like I've said, and I'll talk a little bit about my education. So I was having a chat here with Barad just a few minutes ago, and it's important to know how did my journey start, because I know that we all have different journey into this data science. So for me, it started with my bachelor's was in chemistry and education, and I loved chemistry and I love teaching chemistry. So I took up a job as a chemistry teacher, and gradually, maybe because of the kind of friends I made, I started having interest in technology. Then I went back to school to get a master's in educational technology. After I got a master's in educational technology, I was growing my interest in technology, but trying to see how I can integrate chemistry into it. So I took another master's in chemistry. And after doing that, I realized I don't think that's the route I want to go to. Like, I think technology is taking more of my time and interest. Then that pushed me to go for a PhD, and my PhD was in technology. So I majored in artificial intelligence, and I work with data, numbers, images majorly. And because, well, to an average person, an image is like a photograph. But for somebody involved in computer, you know that essentially an image is just numbers, pixel data, nothing more than that. Like, it's visually beautiful, but it's all numbers. So presently I work with Memorial Sloan Kettering Cancer Center as a data scientist, and I do computer vision works, working with radiologists, images, different images, and trying to make sense of what these images represent and see if the doctor's brain and years of study can be put into an algorithm that can make their work faster, or can work with them to reduce the bottleneck in healthcare data and patient diagnosis. So currently I live in New York, and yeah, that's about me. So today we'll be talking about data, and we say, like, it's a common slogan that data is everywhere. Like, data has become like the largest ocean in the world currently. And Bruce Schneider said that data is the pollution problem caused by information technology, and privacy is the environmental challenge that we have here. So when you hear chemists talks about global warming and how we can save the environment, well, privacy is like the challenge, the environmental challenge that we have when it comes to data. So healthcare data, what is it actually made of? Well, there are so many different types of health data, but I'm going to focus on just these 5, because I think it's what at one time or the other we've had experiences of. So when you go to the hospital for an examination, your data is collected. No matter what you go for, even if it is just a wellness check, your height is checked, your weight is checked, your blood pressure, the nurse asks you, what are your worries or concerns today? And all of those are put into a particular database. Then the doctor comes to see you, and the doctor also collects data, and all of this data is kept and is stored under your name. Then we also have patient-generated health data. And when we talk that, most of the time, patient-generated health data is, well, we can talk of devices that patients are connected to, but it's also information that is provided by family members, maybe for our patients, patients who are out of the hospital, or data that is collected in between visits. So doctor can say, okay, take this data, let's see, come back in 2 weeks and let's see what your symptoms are. Let's see if there's an improvement or other stuff like that. Then we also have lab results. This is very popular. We go to the hospital, we are asked to take it, to go for a test, and the laboratory test is out. We are notified, our doctor is notified, and that goes into the healthcare database. Medical imaging, well, like a statistic recently showed that 75% of healthcare data is actually medical images. And when we talk medical images, you're talking CT scan, MRI scan, ultrasound. Even unborn babies have images stored about them, like things that project who this child is going, what this child is going to be, sex, heartbeat, and so many other things that are recorded at that time. Then we also have inpatient health monitoring. This concerns patients that are hospitalized at one time or the other. Now, when we talk about all these images, something that is very important to put in mind is that these images are stored in different, this data has stored in different databases. So the lab attendants have somewhere is storing my lab data. So when I go for an MRI scan, the machine takes the scan, it is stored somewhere. This information is sent to my radiologist to interpret, it is stored somewhere. The radiologist sends this information to the doctor that attends to me, my personal physician. This is also stored somewhere. If I need to see a specialist, I go to the specialist, my data is stored in another database. So we are talking of several databases. And this is where it is important for us to consider privacy and security issues. Because even when a data that is collected somewhere seem mega or minute or not important to me, the fact that someone has access to that database can compromise another information that I have stored somewhere. So like this morning, I was still listening to Latina. She's a professor at Harvard University. And one of her papers that made a wave was how he reviewed the healthcare data of the governor of Massachusetts at that time. And how did she do it? All she needed to do was pay $20 to collect voters registration data. She got this data. Through this data, she was able to, even when some form of PHI was removed from the healthcare data set, not all of it at that time, because that time, the sensitivity about privacy concerns in healthcare was not as much because it doesn't look like as important. If you talk credit card fraud, oh, that's like a big thing. But in healthcare, it seems like not important. But she got this data just for the use of 5-digit zip code. She was able to say, okay, in this data set, this particular person is the governor of Massachusetts, and she was right. And that brought up a lot of policies and talks, IPA and things like that about what to remove and what not to remove. Another situation was when Netflix released data online. That is not anything about healthcare. But how did the scientists who reviewed, we know the people whose data you published online did it. They only use IMDb data set. So the challenge here is that even when these data sets appear to be standalone, they have data in them that links one database to another. And it will be surprising to know that somebody's little information, as little as address, date they visit the hospital, can be important and expose that person to attacks or something else. So the healthcare data set is growing, and it's a very large data set. It's very big. They have to keep everything for a very long time as well. So like in 2020, it was projected that 985 exabytes of data is what data centers can keep. But the projected data set in healthcare at that time is to make up 2,314 exabytes of data. Where will this data set be kept? Now, the most important thing we are talking about here is that the healthcare data set is a huge one. It's big. And that is why it is important that something is done about it. Now, a data scientist's role in healthcare varies. Some people work with drug discovery. I have friends who literally know, even when they're data scientists, they really don't know anything about the data I'm working on or anything about the data I'm working on. So it's like saying, oh, here's my data. And they look at me and like, well, it makes sense to you, it doesn't make any sense to me, because that is what they work on. Some other people work on genomics and genetics. I remember a time I was asked to work on a data like that, just in a training. And I was looking at the HBCG kind of repetition, and it was really strange to me. I was looking at it and I'm like, well, it makes sense to you, but it doesn't make sense to me. Like, what do I want to do with these genes? Well, and they're like, oh, can't you see the patterns? Can't you see this in and out of it? Like, can't you notice this? But for me, it was strange. I couldn't see what they're seeing because I don't work with that kind of data sets. I have little or no knowledge about it. So some other people work in data management. Some other people work in building virtual assistants and how that helps the healthcare industry as a whole. Image analysis, that is what I do. Some other people do predictive analysis. it's funny how some people can be able to go through somebody's gene and be able to predict whether they are going to develop a form of cancer or the other in the future because of the kind of gene they have, or if they have potential of having this kind of ailment or not. And all of this information are important, even when we don't wear the white coats, even when we don't attend to patients, even when we don't interface with patients literally. Like a patient that uses Sloan does not know me because I've never had anything to do with him or her. And they don't even know that I exist. But there's something that belongs to them that can be with me. That if somebody is able to loop through me, they have access to their information. And that is where the data scientist in healthcare needs to understand what position they are occupying and how important the position they are occupying is. So somebody can say, oh, you don't tell a lie to your doctor. That's very true. You tell your doctor everything, but your doctor puts that information into a database. That database is given to another person to work with. And that person you don't know and you know nothing about. And even when the data scientist does not seem like the white coat medical doctor that can give access to information, he or she has access to a lot, which must be protected. And in the data science pipeline, when we do a lot of things, something that loops all of the things we do with data together is data protection, pseudonymization and mechanisms. Pseudonymization mechanisms, because when this is not properly done, somebody's information can be compromised. When this is not properly taken care of, somebody's information can be used for different things. I was talking with someone recently, and the person was asking me about what I do. And after we have spoken for some minutes, it was just like, well, so there's another person there, and he asked her what she does as well. So she was like, well, I do data analysis, and I try to ensure that patients' data are not exposed. So it was like, how do I care whether you expose my data or not? Like, what's important? Like, I have a kind of disease. I have COVID-19 or something. So it was just talking from the diagnosis perspective. So when he said that, we busted into laughter. It was funny. This person is educated. This person is well-read. This person is exposed. And he's like, how do I care if somebody knows I'm sick or not? So we took time to talk to him, and we were just like, do you know that your medical records carry your name? Your medical record carry your birth date. Your medical record carry your treatment date, the date you visited hospital, admission date, discharge date, whatever. It shows your telephone numbers. You don't give your hospital a fake telephone number. You give them the right one. So if I have access to your health record, I have access to your telephone number, your contact information, address, in some cases, social security number. Like, all of these are the information you need to give me. Even when I literally don't collect any other thing from you than to attend to your ailment and treat you. And with this information, if somebody have access to your social security number, what do you think that talks about? How safe do you think your credit cards are? How safe do you think your kids are? Because when I know your family history, I can access those data. Your education information. We are talking different informations that are linked together. And it was like, wow, I never thought of that. That anytime he hears about all these healthcare data and things like that, it's like, and I'm like, well, I could identify with you. I remember sometimes ago, well, I was already working with data, but I went to the hospital to collect vaccination records for my son to use at school. So I filled the form online. I got to and they were not releasing the information. So I went to the hospital and I was like, I need this medical record for school and stuff like that. And they're like, you didn't sign an authorization form. So I looked at them and I'm like, but I faxed this thing from school. It's like, no, we can't release it until you sign an authorization form. It was like too much of an effort into what does not really matter. Like I'm talking vaccination record for my son. But after I advanced a little bit more and started working in healthcare, I understood the reason why they had to take all of that precaution, because all this information, even when it looks like a little bit of something, it's very important. Why talk about data privacy and security in healthcare? I already started, but something that I want us to look at from this slide are healthcare data breaches that are happening. This statistics is for 2018. And if you look at it well, the frequency shows 466 incidents. Like that is how frequent it was. And the top 3 patterns were due to miscellaneous errors, web applications, and privilege misuse. I'm going to delve into that a little later. Then the data that is compromised, 72% of the data compromised were medical information. 34% of them were personal. 25% were credentials. We are talking information that are important, information that gives you an access to somebody beyond what they will readily release themselves to produce. And they also provided data about the actor motives and, of course, financial. That's the highest. Like most of the time, hackers don't just do their job because they just need the data. They do it because they need the money. So financial is the most important. But it's funny to see 3% are due to grudges. Maybe political grudges, maybe, I don't know, different grudges, political parties, different people seeking something to put out there to expose someone because they hate something about them. So 3% is due to convenience. They just want to show that we can bridge your healthcare data set, even when sometimes they don't consider how much this will cost this facility. These bridges are different from one place to another, and threat actors, 59% of threat actors are internal. That is concerning. And you talk of people who work with health insurance companies, people who work with government, medical companies, and different people doing different things to just look into, to bridge into the database of one healthcare facility or the other. But you know, sometimes this thing don't look important because we don't know how much it affects. I'm going to give some examples. So, for example, in Missouri, Capital Regional Medical Center, there was a day, it eventually slipped into 3 days. Patients could not access their website and all calls were also down. Like different people went online to start stating different things and their concerns about that. So think of people who have to do prescription update. Like, you know, it happens that it's like, oh, I have just one more. Or you call your mom and you're like, oh, do you have your prescriptions in? And he said, no. He said, oh, you need it tomorrow. Let me get in touch with the hospital. You call the hospital, lines are down. You check the website, you couldn't even reach. I live in New York. Your mom is somewhere in Missouri. She cannot go out by herself. How do you get to the hospital? How do you get this information? So we are talking numbers that affect real life people. In Alice University Hospital this hospital is in Germany. It's even an healthcare center for a university. So when this breach happened, the hackers actually didn't know that they were breaching the information of an hospital. Their target was the university, but they got into the hospital data set. And what happened was lines were down, people couldn't make contact, different thing, the commotions that happens. But the sad thing was that a patient was actually lost because the patient was on referral to another institution and they couldn't just access the healthcare data of that patient. That led to the loss of life of that data. Would the patient have died? Well, maybe, but the thing is, how different would the story have been if they've been able to access the data of that patient and work on the patient immediately? So these bridges are important, and that's the reason bridges are important, and that's the reason why we have to talk about it. Now, another study, this study was published in 2020, and it's amazing to know that when you talk data breach incidents, healthcare stands out. People try to breach government data, NGO, different people education data, but why do they target healthcare? Because healthcare is where you have a lot of people's private information. And it is where people don't know a lot about how important it is to keep this data safe. There are different incidents with healthcare data sets. And in this table, something I want us to notice is that unintentional disclosures actually is the most important way that breaches happen. It has the highest number of breaches, or the source to breaches. So while hacking is very, very popular, and hacking requires a lot of efforts from programmers, coders, people who are involved in this, unintentional disclosures is actually stands out like the major source of threats. And that's the reason why I'm talking to data scientists about this, because this is something that we need to be careful of when we handle a lot of healthcare data. So data privacy, data security. In privacy, you are focused on how to collect, process, and share and delete data appropriately, and how I am protected as a patient to determine what part of my data I want to authorize to be given to another person, and when they should be and how they should be. In data security, we are talking about how to protect third party from accessing what we have in our database as an healthcare industry. Data security, this is very popular. Most important thing is confidentiality. These are policies that must be put in place. It is important that electronic PHIs are not illegally disclosed without proper patient authorization. Then the integrity of electronic PHIs in terms of transfer and maintenance by healthcare organization should only be assessed by authorized parties. That is when we maintain the integrity of our data. And talk of availability, patients should be allowed to access their ePHI under HIPAA security standards. So maybe many of us on this call don't even check our patient portal. It's your right, and you have the right to access it and determine who accesses that or not. Then talk data privacy. Traceability is an important thing to talk about, and that is the ability to verify the history, the location, and use of a data. It answers the question, who have access to my data? When do they have access to it? What do they have access to? And the why question. Linkability. Are we able to prevent leakages? Like, what is the possibility of linking this record with another one if the data is put together and compared? So this is something to look into. Privacy, any data that is going to be, that can be linked to another thing, or that can be linked with another database to have access to the patient data, must be well taken care of. Identifiability, can the data be used to find PHI? So one very important information that I don't take serious, and I was surprised at how it could be used, is people's addresses, zip codes. That doesn't really appear important. Like if you Google my name, you probably find all the apartments I've lived in since I got to the United States. That doesn't look so important. Like some people put it out there, but that information is enough to get my PHI. You have my name already there. Just because you search for my address somewhere, or from an apartment information or something. And a similar thing happens in healthcare as well. So now, administrative safeguards, when you talk healthcare, you talk HIPAA. This policy is very important. There are some other security policies that are put in place to FEPA, SOC, GDPR. All of these policies are considered in healthcare. And you have administrative safeguards, physical safeguards, technical safeguards. So as I'm using my laptop to do this presentation, it will be funny for you to know that you cannot copy anything from this laptop because USB access is denied. So, and why is that? Because I'm a data scientist and I'm working with patient's information. If my USB is, if access is granted, the possibility is a friend comes to my laptop. Oh, I love this music you're playing. Do you have it downloaded? I'm like, yes. They put USB in my laptop to copy the song, but guess what they have? They have access to some other information on my laptop too, except I have put that under another security protocol. So all of these are what institutions does for us. So when you talk technical safeguards, website is monitored, different things are put in place. Security personnel do a lot of work. They try to make sure that they check all the check boxes in the policies, because really they're the first point of call if any breach happen, and they will bear the grunt most of the time. So there are several things that they put in place, but something that they cannot do for me is that they cannot check me beyond me. Like, I'm an individual. I have access to my privacy. I have access to whatever thing I want to do. So even when they put all of these things in place, as a data scientist, I'm a weak point for patients' data, and they cannot absolutely control me. So I'm a weak point of attack that other people can get information from or attack the organization from. So ethics in healthcare data, so many things: identify relevant substantive information, weigh relevant ethical merits. Like, these are things that are looked at to decide, oh, how much data should be released, how much should be removed, what should be done about this, and stuff like that. So as a data scientist, what are the privacy techniques that we try to put in place? One form of privacy technique is pseudonymization, and this involves scrambling. So when you talk scrambling, like the example I gave you, this is very simple, everyday maths. We've all done it one way or the other, one time or the other before, when we need to send a secret message to our friend somehow. All I needed to do is to mix the data all. So when you have Adebunmi and you see mine had both, it doesn't look like the same thing. So this is a simple technique. Another technique is encryption. That's very popular, but the thing is, this cannot be done without algorithms. So you have the encryption key, you have the decryption key. So the data can only be reversed or checked back if I have the decryption key. Another thing is masking. This is just replacing information with like XXS or something else that we denote it to. Then tokenization. It's just, in this situation, you have a token vault where the true data and what is like a substitute is put into. So one thing that needs to be protected to make this effective is the token vault, but that's another system that is used. So you put a substitute that may not really look relevant or important, or cannot even provide information to anybody else, because that information is not true. So it's like saying that a number is 1, 2, 3, 4, and I substitute it with 5, 6, 7, 8. Then we also use data blurring. This is very common, especially with images, like blurring people's faces and stuff like that. Like data blurring, not just about images. There's some other data you can do blurring with. You are just rendering something obsolete, like access is reduced. Another technique that is popularly used is key anonymity. And this is just to protect the privacy of individual person by pulling their attributes into groups. So for example, zip code. Can we put zip code into a group? Or can we just do some form of masking for the zip code to make it look general? So like, for example, 47906, one very important identifier there is 06. But when that is masked, there are so many zip codes that fall under the category of 479. Or for age group, instead of putting in age 25, you do a 20 to 29, or 20 to, or 25 to 30, something like that. So that generalization reduces ability to trace people's PHI. Another thing is suppression. So in suppression, it's removing information that you don't need. For example, I'm trying to create a model that will be able to identify lesions, maybe in pelvic bone scans. The thing is, even when I have access to the patient age or their sex and other information, since I don't need it for my study, I don't need to keep that information. I don't need to download it at all. Then another technique that is commonly used is differential privacy. Differential privacy is a lot popular. It is just introducing randomness. Big tech companies use it. So it seems like one of the leading ways of protecting data now. And there are different mechanisms that can be used. So we talk Laplacian mechanism, it's just using Laplacian function. I think the Laplacian mechanism is one of the most popular ones, followed by Gaussian or exponential mechanism. So all of this is like you're building a mathematical model that is generating random noise using these functions, and it's able to introduce that function into the data set. And this random noise makes it impossible to access personal information. Then we also talk about composition theorem. In addition to noise addition, differential privacy also have two theorems, like composition theorems, and you talk sequential composition and parallel composition. Now, the pros and cons of these methods. Like I said, I defer more to differential privacy because it has low complexity, original data is not lost, and privacy can be controlled according to need by varying the privacy parameter. The only challenge here is dimensionality, cost, and selecting trade-off. Like you have to decide which is important, privacy or accuracy, because we are talking of statistical modeling. My model will have no meaning if, because I want to keep somebody's information, I introduce so much noise that my model is not performing well, or is bringing output that has nothing to do with what the information I already know. Like, for example, I was working on a data set recently, and I tried to do some form of differential privacy. I introduced noise, and at the end of the day, the model was not performing well at all because I have introduced too much noise. So I had to get to a place that I look at what is my trade-off: introducing noise, too much noise, or just having a model that works perfectly. So sometimes we are faced with this challenge, but in terms of other ones, they are also simple, but in most cases, the original data is lost. So the data is not lost, but there are so many algorithms out there that can decrypt some things that you think you have encrypted. So it has a lot of challenges, computational complexity, speed, and so many other things that may not make it appear so usable. Take, for example, this thing is computationally complex, taking a lot of time that the doctor cannot even access the data that was collected at the lab because PHI was being removed. So all of these are things that need to be considered. So security best practices for data scientists, which is like the important part of what I want to talk about today. Like, as a data scientist, when you work with healthcare data, what are things that you can do or that you're expected to do by yourself, even when the hospital is providing or the institution is providing a lot of protection, privacy, security, enforcing a lot of policy? What are you supposed to do as a person who works with patients' data and does not want to become the bridge point for this data? The first thing I recommend here is use only what you need. Like I said, one of the techniques, you don't need to collect more information than you need. What do you need at the moment? What do you need it for? When you know what you need and the information you need, why not only use what you need? There's something that is frequently done in my hospital, and that is trying to, so of course, whenever you access one database or the other, there's a log created for it. And something the security people have put in place is to, once in a while, run an algorithm on the log information that is able to look at who the person that is accessing this information from, who this person is, and the access, the information they are accessing. So if they notice that you are this person that is going to see something, because it is a privacy policy, you don't access a patient data except you need to do so. So the fact that I know that the governor uses my hospital and I have access to the governor's data, I am not expected to go and see why the governor is in the hospital or the things he or she is dealing with. But once in a while, like the gossip human factor makes data scientists use that data power to access some other things. So there's this algorithm that they run that matches, are you supposed to access this information or not? And if you are caught not doing it, if you are caught doing that when you don't need to, that is something that you can be discharged on. So use only what you need. You need. Minimize what you store. If you don't need it, don't collect it. Even when it is for a study, if you don't need it, don't collect it. If you don't need to use it, don't have it anyway. Secure more than your databases. So when security is provided for databases, what happens to your laptop? You don't need to download on your laptop what you don't need. And I see some people tempted to download hospital data on their personal laptop. That is a no thing to do. You don't do that, because your personal laptop is not completely protected like your work computer is. So these are things that people do. Emails, like as a data scientist, am I supposed to click on a link that I don't know? These are things that they test once in a while and send something like, oh, something tempting. But even when it is tempting, we should be conscious of that. You don't need to. You need to be conscious of security beyond database, your emails, and so many other things. Establish a clear governance policy. What are the policies that you are abiding with in your work area, in your data group, in a study? What are the policies that are important for that study? Ensuring that one is compliant with that is a way to keep one's job. Encrypt and mask as much as possible. We can't say this enough. Although they say if a data is overprotected, then it probably become not usable. Like there is no way you can do it. Somebody or something has to be the weak point. Even when you have a vault where you keep your tokens, somebody needs to have access to that vault to be able to access that information. So another thing is collaborate carefully. I use the word collaboration because sometimes we work with people who are not exactly in our institution. Like I can be working with someone in an insurance company who has nothing to do with my industry or has little to do, and I'm working on data. The thing is, all of these collaborations needs to be done carefully. And something that I try to look at from the point of view of collaboration is also family members, friends, kids who have access, who knows your who have access to your phone. It's funny that the kids that we are breeding these days are digital natives and they know all of these things. So this child knows that even if it is multi-factor authentication, I know the app that does it on mom's phone. All you need to do is authenticate it and voila, the child has access. So collaborate carefully. And something that I will conclude with is train and retrain. Well, we hear all of these things every time, but sometimes it's easy to forget, or it's hard to keep up with so many things that we are required to do. And I also say be up to date. It's important to be up to date about the information that we need, or about the information that is needed. Different things are coming out, different bridges. Like if it happens to hospital A, it can happen to B. So be up to date. What are the things hackers are looking out for? What are the things they're talking about? What are the things they're doing in the industry? Because don't forget this, the healthcare industry is actually not an information technology industry. But the thing is, because of the amount of information technology that is used, electronic health records that are kept, it's important that we are up to date on what is happening so that we also know how to stay abreast and be at the top of our game. I hope that one way or the other I've said something that is interesting or something that you think is important, but whether you like it or not, you are also a data that is being collected, and you are a weak point, and you determine what access you give and what you don't release. Thank you very much.
Thank you very much. Thank you very much. It's very informative, and it's really helpful for us to see. It's kind of also scary a bit when you mentioned about that, because it's true. We go into the doctor, we always have to tell them the truth, like always, all kind of information that they needed, whether we like about our diet or about like our habit, anything, and they may need to note them down. And I never thought about where do they store the data, or like will that data being shared with anyone? Even though I work in this field, I was aware of other part that is also scary, but this is
Yeah,
scary.
it can be.
Yeah, so right now we will move into the Q&A session. We have collected a lot of questions from our audience, and so I will start asking you some questions from the audience, ranking from the highest voted question. So the first question is that, based on your experience, what are the typical ways to determine the balance between the accuracy versus privacy trade-off during modeling? So you mentioned that in the part of differential privacy technique. Yeah.
So from my experience, there are different things to look at. And one thing that I do is, well, it's important that we are doing, we want to find this trade-off. Like some people these days, you just do a kind of probability. What is the probability that this data set can get leaked? What is the probability that if this information that I'm trying to remove or trying to mask is leaked, it can affect my healthcare industry? Because really, if MSK data set is leaked through me, well, maybe I can get discharged if they find out I'm the source, but most importantly, they'll be the one to pay. They'll be the one to pay ransom or pay to individuals whose data were breached or something like that. So one important thing is, well, probability of how much this information will be important. So for example, like I said, I work with RAD images. Like on this image, can I crop it in such a form that nothing about that is noted in the machine is showing? And if none of that is showing, do I need to introduce any other noise in that data set to mask it from being identifiable? And is it possible that somebody is able to see this scan and another scan and be able to tell that it belongs to this person? So, and don't forget, like we were talking about databases. So when I get a scan to work with or to analyze as a data scientist, it has gone through the radiologist, right? That person has been able to make diagnoses on it. But the thing is, because I want to work on this data, I'm given access to the radiologist database. And that is where the challenge comes in. So when I have access to the radiologist database, I have access to much more than the information that I need. I have access to the person's age. I have access to the sex. I have access to medical history, which are the things that are important for the radiologist to be able to determine what this person's diagnosis actually is. So I would say just some of it has just questions of speaking with maybe your senior or somebody you're working with, or your manager or supervisor, about what information is actually important for this analysis. So for example, why I said speak is, somebody wants a model that is able to not only say this full image has a lesion or a fracture, but I also want it to tell gender. Now, because my boss wants gender involved, I do not have a choice. When I'm weighing between privacy and security and what is important and what is not important, how much noise to introduce, then I don't have a choice. The sex information is important for the success of what I'm working on. So I need that. So all I need to do is, I don't have a choice. I can't compromise masking that information for having a better model. I don't know if I've been able to answer that question, but it involves a lot of weighing. Some people use probability, some people use some other form of just thinking through what information is important and what is not important, and just decide what noise to include, what noise to remove.
Interesting. Okay, thank you. I think that's really important, like tied to one of the talk in this morning when they said that like always like having the scope in mind and
Yes.
talking with like different like stakeholder to determine that. And so I think that is not just a data question, but also if you can remove that ahead of time, then maybe you don't even have to worry about that. Okay, so the second question is that you mentioned that healthcare data has to be kept for a long time. Is there a reason why?
Okay, well, in fact, there's some information that don't need to be kept for too long. But now, is there a reason why? Yes. And why is that? So the thing is, these things goes into archives because at one time or the other, something needs to be pulled off from it. But imagine how much information you give, especially when you're providing family history. The infections you've had before, like on the list, maybe there are like 40, in some forms, there are like about 40 things you have to tick off that I've had before, I've been diagnosed of this before, or somebody has it or something like that. So that itself, it's a lot of information that we are given. But basically, in the HIPAA policy, there are some healthcare data that only needs to be kept for 6 months. There are some that needs to be kept more than that. So like if you go to my physician cannot delete my information in 6 months because this person continues to be my doctor. So like my gynecologist cannot just delete my information after. So these informations have different categories, but a bulk of them, which no matter how least you consider it, contains at least 5 to 6 PHI, has to be kept like almost as long as a patient of this hospital. Now, when you withdraw from this hospital, for example, in terms of death, then there's a determination of how soon the information can be deleted. But in most cases, it's like kept almost for until like it is evident that it is not required at all by anybody again. So it's not like academic records that is only kept for a short time, like for 4 years. We are talking information that is kept for a very long time and contains various information. So yeah, that's the reason why. It's just plain, I need access to my data. I know that, oh, I use this, for example, sorry, this is taking a longer time. So I have an incident and I need my dental records because my child is diagnosed of something. And the doctor I used when I was a kid, the hospital is still alive. All I need is to contact that hospital to say, oh, I need my record to be compared with my son's record. And so like, it's not something somebody has to just decide and say, oh, let's trash it. It's been 10 years. Nobody's going to come back. They don't need it again. Yeah.
Oh, wow. Okay. So I know we are like near the end of our time. So I will see if I can, how many more questions we can squeeze in. We still have a lot of questions.
I
So
already
another
have
question.
a notification asking me to join another room.
Oh, I'm
no,
sorry.
No.
Yeah.
Okay. It's not. Yeah. So the next question that we have is that did these data breaches exist when all medical records, or if or when all medical records were kept on paper? So it seems like lots of them will exist because of the digitalization.
Sorry, I didn't hear the question well.
So the question is that, did these data breaches exist when all the medical records were kept on paper?
Oh, life was beautiful when it's old, like it seems. Everybody says we remember the good old days, but unfortunately, nobody will go back to the good old days. So we deal with what we have at hand, and well, the paper records were good, but they are not as good as the electronic records. I tell you, like it was good when you were writing letters every time, but you can't compare that to emails. You can't compare that to text messaging. Yeah, so it's just the same way. But it's good but we can't live in that world again. Technology has changed the world for us, and we just have to enjoy and manage it.
Okay, and then I have one last question before we will go into the break. Does healthcare data being shared with insurance company? I feel like if people can predict who might have cancer based on their gene, it would be, oh, the question is disappear for some reason. It would be a discrimination for the insurance company to use that data outside of the person ability.
Well, I want to assume that I understand what this person is talking about, because sometimes ago I watched something, and what was this information about? This person uses not an Apple Watch, but all these Fitbit and some of these technologies that measures sleep and has a sleep tracker on that wearable device. Then they developed a form of ailment, or something was not going well. So insurance company was booked to pay for that treatment, and insurance company comes back to say, no, we're not going to pay for that, because you're meant to be sleeping for 8 hours when you're on this drug to get improvement, but you only sleep for an average of six hours. And the person was like, how did you get to know that? Guess what? Insurance company bought the data from somewhere. And that's one of the reasons why we talk about linkage data. So hackers are doing this mostly to make money. So somebody hacks a database, sell it to another company. Like, you can't hack this insurance company. Where did you get this from? Oh, they will not absolutely reveal it. But everybody is using one information or the other to sell their business. That looks very much like a breach of private information. But the thing is, somewhere was breached to access that data, and that is just this person's wearable device that doesn't look important. So it's a complex thing, something to be aware of. But yeah, it's the information technology world, and we just have to deal with this problem at hand and be much more conscious of where our data goes to and how it is kept.
Wow, that's really crazy. My partner does have like a watch that is like a smart watch that can track like sleeping and all kind of activities. We're definitely gonna look into that. That's really okay. So with that, I know I couldn't get to all of the questions. So if you are interested in asking more questions, please feel free to, if you see in the screen, you can still see her email. Feel free to send her email, or can just send to us, and we can help you to answer more of your questions. With that, thank you so much for coming here today and share with us your thought and knowledge on this data ethics and privacy.
Yeah, pleasure. Thank you so much for having me. I appreciate it so much.
Thank you. Okay, so with that, we will have a few minutes break, and we'll come back in 2:40, so around 5-minute break, and then the next talk will start at like 2:40. So if you need to grab a cup of water or run to the washroom break, it's like this now is the time.